Oh, hello there. I didn't realize you were there. So, I'm pretty sure you clicked this video because you want to know more in detail about the reaction turbine, right? So one of the interesting facts that I know is that most of the houses in Malaysia are generated with electricity through the dams. And the dams contain reaction turbine, which generates electricity through the houses. So, today, my groupmates and I.
Hello there. Hello. I'm and yeah, I'm Nurul Nazran.
So we'll be explaining more in detail about the reaction turbine. So in this video, we'll be explaining about 4 major things. So the 4 things that we'll be explaining in this video is, the first one is the process flow of the reaction turbine. The second one is the major components of the reaction turbine. The third one is ways to improve the efficiency of the reaction turbine. And the fourth one is the functionality of the reaction turbine itself. So stay tuned. Alright guys, listen up. I'll be explaining about the functionality of the turbine itself, okay? So the turbine is basically a rotary machine that is designed to capture some of the energy from a fluid, such as
Liquid or gas?
Liquid or gas. And it converts it into mechanical work so it can be put to use. So as the fluid passes the blades, it will rotate, and removing some of the fluid's kinetic energy and converting it into mechanical work, thus converting it into electrical energy. Okay, so one of the examples of reaction turbine is the windmill. So the faster the wind blows, the more energy it contains. So this causes the sail to spin a lot faster, thus supplying more energy to the mill. However, as the wind passes through the windmill, the wind blows just a bit more slowly when it passes through the sails. So this shows that some of the energy is given up to the mill itself. Right, so now that Vicky have explained to you the process flow of the reaction turbine, as of right now, I'll be explaining to you the components of the reaction turbine in general, okay? So come a little bit closer. Alright, so as you can see here, this is the housing of the turbine itself. Right over here, this green one, this is the guide pulley. And this thing over here is the signal processing, and over here is the water feed connection. So as you can see here, this is the housing of the turbine, This is the housing of the turbine. And this green thing here, this is the water feed connection. And right over here, can you zoom in a little bit? Okay, so this is the tensioning bolt.
Hi guys, now you already know the main component of the reaction turbine. Right now I will explain to you on ways to improve the efficiency of the reaction turbine. Okay, first of all, we must to make sure the equipment is in a good condition, where is the machinery and the wiring in a good maintenance, so there will be no errors on our result or damage the equipment. Secondly, before conducting any experiment, it must to read the lab manual first in order to understand the procedure before conducting the experiment. If something goes wrong or you do not fully understand the experiment, seek help immediately from the technician to guide you with the experiment. Other than that, make sure that the software was set properly accordingly to to the requirement of the experiment before conducting the experiment. Seek assistance from the technician or lecturer to set the software. Moreover, we must ensure to click the stop button quickly after the needed speed are achieved. Okay, last and but not least, the important thing is make sure the tensioning bolt is adjusted slowly and carefully until the required speed is achieved according to the procedure to get the better result. Thank you.
Thank you very much for your explanation on reaction turbine. I have a few questions for you. The first one is, what is reaction turbine? Okay, the second one is, how many types of reaction turbine? Okay, last one is, what is the difference between impulse and reaction turbine?
Okay, reaction turbine is a turbine which develop mechanical force reacting to the pressure and weight of a fluid. Okay, the operation of the turbine describe Newton's third law, which is action and reaction are equal and opposite. Okay, for reaction turbine, they are separated by two types, which is steam turbine and liquid turbines. Okay, there are many differences between reaction turbine and impulse turbine. So I explain to you guys two only. Okay, for the first, impulse turbine use kinetic energy to rotate the turbine, while for the reaction turbine, kinetic and pressure is used to rotate the turbine. Okay, next, for impulse turbine, water flow through the nozzle and strike the blade of turbine. For reaction turbine, water is guided by guide blade to flow over the turbine.
Okay, since you already know about the function of reaction turbine, the process flow of reaction turbine, and the question from Dr. Amin, so basically today I would like to explain on the main components of reaction turbine. So there are four main components of reaction turbine, which are spiral casing, guided mechanism, draft tube, and lastly but not least, tube turbine runner. So for the first main components are spiral casing. The casing is designed in such that its cross-sectional area goes on reducing uniformly around the circumference. The material used for this casing depends upon the head of water. If the head of water is up to 30 meter, then concrete will be used. But if the head of water is up to 100 meter, welded rolled plate steel will be used. So for the second part of the main components is guided mechanism. Guided mechanism are made from blades and vanes which will guide the water towards the runner. The guided vanes are fixed between two rings in a form of wheel. The function of guide vanes is to allow the water to enter the runner without shock. Next, it also allows the required quantity of water to enter the turbine. Generally, the guide vanes are made from cast iron. Third main components of reaction turbine is the turbine runner. Turbine runner consists of many curved plates which is welded to a circular disc. The surface of runner is very smooth so that it can minimize the frictional loss. If the shaft is vertical, so it will call as a vertical turbine. Same goes to the horizontal turbine.
Okay, next for the franchise turbine. Okay, franchise turbine is working fluids come to the turbine under immense pressure. Okay, for the application of franchise turbine. Okay, units cover a head range from 40 to 600 meter. Its efficiency decrease when the flow decrease. The application of Kaplan turbine. Okay, Kaplan turbine is widely used for the electrical power production. Okay, the water cover the lowest head hydrocycle. This is suited for the high flow conditions. Okay, for last but not least, I will explain about the kinetic turbine. Okay, its name also kinetic, so it's about the flow. Okay, it's called the free flow turbines. Electrical from the kinetic energy presents in the flow water. Okay, the application of the kinetic turbine. Okay, kinetic turbine is the flow of water in the pathway of water, something like drains and pipe. Okay, thank you.
So from all of the explanation on the reaction turbine, I hope you guys get some bit of info and a bit of knowledge about reaction turbine, and I hope you enjoyed this video. And that's all from us, and thank you very much.
Please subscribe.